Hi, welcome to the session for solving the fun probability problem. So today we're going to solve this question here. So this question tells us, suppose we have 6 digits, 0, 1, 2, 3, 4, and 5. And these 6 digits compose a distinct 3 digits number without repetition. And the hundreds place cannot be 0 because I want to have the 3 numbers. So the hundreds has the smallest one that has to be ones here. So what is the probability that a composed number is a multiplier of 6? Wow, very interesting questions here. All right, so now let's go ahead, go to the whiteboard and see how to resolve these problems here. All right, let's go to the whiteboard here. Okay, so let's go ahead and start. All right, so we have 0, 1, 2, 3, 4, 5, right? Okay, so let's first take a look at the total possible cases here. All right, so we have 3 digits numbers here, right? So, and we also have 0, 1, and 2, 3, 4, 5. Okay, so let's take a look. So for the first digit, because we cannot put a 0, so we can put anything else. We have 5 different situations here. And then after we pick up 1, then what is the second digit we have? We have another 5 possible choices here, right? Then the last digits, how many? We have 4 here. So we times it. And so total, we have how many here? So the total, we have 100 here, right? So we have 100 cases here. Okay. Right, so this is the first thing. So this will be our denominator when we try to find the probability. Okay, so the next things here we need to think about. Okay, so let's say there has to be the multiplier of 6. All right, so if it's a multiplier of the 6 here, then you think about the number is a multiplier of the 6. That means that the number is divisible by the 6, right? So we know the number has to be, the whatever the digit we got has to be an even number. All right, so the number has to be an even number if it's multiplied by the 6, because the 6 is equal to, right, 2 times 3, right? So it has to be an even number. Now, what is it has to be here? Whatever this number, because 6 is 2 times 3, right? So it has to be divisible by what? By the 3. Okay, so you say, okay, so it has to be divided by the 3. So what is the characteristic we divide by 3? So if you refresh your memory back to the algebra time, so we say, for example, if I have the 3 digits number, if here I have like 1, 2, 5, okay? So let's take a look at this number. If I have a 1, 2, 5, back to the algebra time, our teacher maybe is an elementary school teacher or the high school the middle school teacher. They tell us the one way is a quick way to see if it's divided by 5 or not is you just add those 3 together, right? So you add these 3 together is what? Is 8. So it's 8. So 8 is not you cannot divide the 3 by 8, right? So if you put 8 divided by 3, it's not equal to a whole number. So now we know this number 125 is not, okay, so it's not divisible by 3. So for example, another one, so if I have 3, 1, let's see here, 315. Okay, so if I have this number 315, is this number I can divide by 3? Then I say, okay, let's add this together. So this one will be 9. Then you say, oh, 9 over 3. Okay, so it's 3, so it's a whole number. So I know this number can be divided by 3. So in fact, if you use like we learned like in the long division, right? So you divide it by 3. So this is the 3. So this is the 0. And then this is a 5, right? So you know this one is divisible by 3. So it's 105 here. Okay, so I have these two things, right? So it has to be a even number. So what is the even number mean? That means whatever these 3 digits numbers here, right? So the last digit has to be 0, has to be 2, has to be 4, correct? All right, so that means the last digit has to be 0, has to be 2, has to be 4 here. So these are the two conditions I need to satisfy here. Okay, so now let's take a look. So I have 6 digits here, right? So I have 6 digits. Now I am going to take 3s here. So I know the total combination of the 6 3, and this will be 6 factorial and 3 factorial and 3 factorial, right? So what is this one here? So this one will be, and I think it's 20s, right? So we have 20 different combinations of the 3 digits here. All right. So now, okay, I will go to the next page because I need the bigger screens here. Okay, so now we know the 6 to the 3, we're going to have 20 situations, combination, right? 20 different combinations. So let's write this one down. So we can take the 0, 1, 2, or 0, 1, 3, or 0, 1, 4, and 0, 1, 5, and 0, 2, 3, 0, 2, 4, and 0, 2, 5, and 0, 3, 4, and 0, 3, 5, and 0, 4, 5. Okay, then we also can have the combination 1, 2, 3, and 1, 2, 4, and 1, 2, 5, and 1, 2, 5, then it's 1, 3, 4, and 1, 3, 5. All right, and 1, 4, 5, and 2, 3, 4, and 2, 3, 5, and 2, 4, 5. Right, so this is 2, 4, 5 here, 2, 4, 5, and 3, 4, 5. Right, so those are the 20 different combinations I'm going to have if I pick the 3 numbers here. So remember, we say, it has to be divisible by 3. So that means you add 3 digits, has to be, that can divide by 3. So I know this will be one of the combination I'm consider. 0, 1, 3, this combination not going to work. Then what is the next one? So this number has to be our combination, and this combination going to be, and this combination going to work, and then this is 1, 2, 3 going to work because they add up is 6. So this is 1 to all this is not going to work here. 1, 3, 5 here, right? Then I'm going to have a 2, 3, 4, and 2, 4, 5, and 3, 4, 5 here. Okay, and so all this combination inside my pink box are going to work, and not all, so what type of the permutation inside will work here. right? So also we know for the 3 digits numbers, right? So for the 3 digits, the largest number we're going to have is 543, right? And the smallest number we're going to have is 102. Correct? All right, because the first digits cannot be zeros here. Okay, now I'm going to combine this one with the the even number condition we just talked about here, right? So I have a 3, that I have a 3 functions here, right? So let's put it here. So yeah, let's put it here. So this is the first number, and this is the second number. This is my last numbers here, right? Okay, so now in here, let's do the same things here. So here, this point. Okay, so here, let's see here. So here, okay, so what happened here? Okay, so here, okay, so here, I can get a little bit longer here, right? So let's assume those are the 3 digits I'm going to have here. Okay, so that's the last ones here has to be 4, 2, 4 or 0, right? Remember, if they want to satisfy the even number conditions here, right? So let's get a little bit bigger. Okay, so now we also know the only numbers going to work will be inside those pink box here, right? So let's take a look. 0, 1, 2. All right, 0, 1, 2. Okay, so in order to work, so I will have 102, right? 102 is work. Now also, I know because the 0 going to work here at the end, right? So what I can have the combinations here is a 2, 1, 0. That's it. That's all the things I have here. Okay, so the next ones here is 0, 1, 5. Right? So 0, so 1, 2. Okay, I'm sorry. Here, this is 1, 2, 0. Also going to work. Correct? Okay, now the next box here is 0, 1, 5. So 0, 1, 5, the only way is the 0 at the end, right? So you have a zeros here. So yes, you have 1, 5, 0 and 5, 1, 0. Correct? All right, so you just go through each box here. Let me extend this line a little bit longer. All right, so now let's take a look at 0 to 4. Okay, so the 0 to 4 here. So, let's got a lot of numbers, right? So they do have a number to end at 2. So which number they end at 2 is we have a 4, 0, 2. Right? And also they have a chance to end at 4, right? So what is here? This is a 204 here. Okay, and also they have the chance to end at zeros, right? So what is the end of 0? You can have 4, 2, 0 and 2, 4 zeros here. Okay, okay, so now the next numbers here is 4, 5, 0, 4, 5. So the only chance is they can end at 4, right? So they can end at 4 here. So 0, 4, 5. So the only one is possible is 504. Right, because you cannot have 0 in the first place. And also these numbers, you can have 0 at the end, right? So what is the 0 at the end? You can have a 4, 5, 0, or you can have a 5, 4, 0. All right? Okay, so now let's take a look at the 1, 2, 3. Okay, so this box here, 1, 2, 3 is here. The only even number you can have is 2. Right? So you can have 132 or 312. Correct? Okay, now the next one's here. is 135. Oh, this one's here is all odd number. So nothing going to work for here for this one. So I know this one is not going to be, even it's divisible by 3, but it's not divisible. It's not even numbers here. Okay, so then the next ones here is 2, 3, 4. Okay, so I know it's going to work with 2, right? So you can have a 3, 4, and the 2, you can have a 4, 3 here. Okay, yeah, because of the end at the 4, so you're going to have a 4 here. So what you can have? You can have a 2, 3, you can have a 3, 2, correct? Okay, so now the last one here, it will be 5, 3, 4, 5. 3, 4, 5, you only have the chance to get a 4 here. And so you're going to have a 3, 5, 4. And the 4, this is a 5, 3, 4. All right, so let's count how many is, let's count how many is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. All right. So, okay, so yeah, I forgot to calculate. So it's 17, 18, 19, 20, right? So let's count again, make sure it's right. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, now from the so we said what is the total number of cases from the previous page? So it's 100 here, right? So what is the probabilities here? So finally our probability will be equal to the 20 over 100 here. So ta-da, we solved it. So this one is very interesting, right? So the key things you need to know is you need to remember multiply by 6. What that means, it has to be an even number, and also is when you add the 3 number together, it has to be divisible by 3, right? They need to satisfy both, and then you'll be able to find it. That's it. Is that fun, right? So it's a very fun problem here. I hope you enjoyed it. Okay, talk to you later for our next fun problems here. Okay, bye-bye.